Hello everyone, my name is Quinn West, and today I'll be going over Cornflower Cipher, one of the color cipher packs made by KTaNE. So, before we actually read anything on the screens, we need to retrieve a binary number from the first character of the serial number. In this case, we have Tango. Instead of just taking the alphabetic position, which is 20, we need to take its base 36 conversion, which is equivalent to its alphabetic position, plus 9. So, this binary digit that we're going to have is 29, and we're going to need this for multiple different steps within the manual. So 29 in binary, let me just think about that. So if we have 16, 8, that's 24, and then 29. So, this is 29 in binary, and we're going to be referring to this throughout the rest of the steps. So, let's start. Step 1 is ping pong straddling checkerboard cipher. And for this, we need to concatenate the last grid on page 1 and the first grid on page 2. So let's do that. UVPU. Next page is IEOV. Don't need this 29 anymore. So, we also need these two words, keyword 1, which is devoted, and keyword 2, which is apathy. So, now that we have keyword 1, keyword 2, and this encrypted word, we also need to figure out what D1 and D2 are. So D1, in this case, is the number of indicators, mod 6, in this case is 3. D2 is equal to the number of ports, mod 6, in this case it's 2. If D2 were to be equal to D1, you just add 1 and then do the mod 6 again. So, let's see what we need to do. First, we need to take key 1, in this case it's devoted, remove any duplicated letters, in this case it would just be the E and D at the end. Take the alphabet, which I should have prepared for this. One moment. Okay, we take the alphabet, and then we need to remove DEVOT from there. So let me just do that with some regex. And let's figure out where we need to place DEVOT within the string. So if the 8-bit is a 1, the 8-bit referring to this original binary number that we got, we place the alphabet after the keyword, otherwise before it. So in this case, the 8-bit is a 1, so the alphabet goes after. So we're doing it like this. So now, we need to make a straddling checkerboard. I actually need to add a little more room for this. With a straddling checkerboard, we need to have a table with 5 rows of 6 columns. Something like this. So the columns will be labeled 0 through 5, and along the right, we need to have 0 through 5 removing what D1 and D2 equal. So we don't have 0, we don't have 1. We have 2 as D2, so we skip it. We have 3 is D1, so we skip it. So then we just have 4 and 5. Okay, wait, is this actually 5 rows? Ah, excuse me. This needs to be shifted down 1, and this is just an extra row. So, we need to fill this string into this table. However, we need to determine if it's column order or row order. But before we even do that, we actually need to reserve spaces for 3 and 2. So we are going to have the letters in these two spots, but these are going to be ignored. So this is 6 by 4, which is 26, or is 24, plus these two is 26, which is equal to our string. So now we need to figure out how to fill this. If the 16-bit is a 1, you use column order, otherwise use reading order. So in this case, the 16-bit is a 1, so we're gonna just go top to bottom from left to right. So let's do that. D E V O. I wish I had a better way of doing this. T A B C. F G H I J K L M N P Q R S U W X Y and Z. So now this is the first table. Next we take this encrypted string and then find it within this table, taking the row first, then the column. In this case, U is going to be row 5, column 4. V is row 4, column 0. P is 5, 3. U is 5, 4. We have that already. I, where is that? It's right here, which is 4, 2. E is, where can I find it? Is 1, 0. O is 5, 0. And V, which we had before, which is 4, 0. So this is the number string that we have, which we're going to need when making the second table. So for the second table, instead of using keyword 1, we're going to be using keyword 2. So it's the same process. Remove any duplicate letters, take this word and then remove it from the alphabet. Just do that. Okay. And now instead of D1 and D2, we need more values. So in this case, D3 and D4 is what we're looking for. D3 is equal to the number of batteries, mod 6. In this case, that is 2. And D4 is equal to the number of lit indicators, mod 6. In this case, it's 3. So we're going to be doing this again. Additionally, we don't need D1, D2, or this table anymore, or even this keyword here. So we can delete all of that. So it's the same process. 0, 1, 2, 3, 4, 5. We need 5 rows of this. And along the right, we skip the first one. 0, 1, 2, and 3 we have. 4 and 5. So coincidentally, it's just the same process, but there's the same rows that are being removed, but you'd be doing this the same way. So if D3, for example, were to be a 1, you'd skip 1 and have a 2 here. But we don't have that. So we need to reserve 2 and 3 for letters. 0, this 0 and 1, this 4 and 5 are nothing. So now we need to fill this with our alphabet. So before we even do that, we need to figure out what word we're placing the alphabet, if it's before or after. So instead of keyword 1, so we need to use bit 2 to determine if the alphabet goes before or after. So let's refer back up here. If bit 8 is 1, but in this case we're using bit 2, place after or otherwise before. So bit 2 is 0, so therefore apathy here is going after this alphabet. And instead of using bit 16, use the fill we're using bit 4. Bit 4 is a 1, which refers to column order right here. So we need to fill this in column order. B, C, D, E, F, G, I, J, K, L, M, M, N, O, Q, R, S, U, V, W, X, Z, A, P, T, H, Y. And now with this number string that we have on here, we need to we need to encrypt these into letters. So, or decrypt rather. So 5, 4 is an A, 4, 0 is a D, 5, 3 is a V, 5, 4, is a V, and I typed an F, 5, 4 is another A, 4, 2 is an N, 1, 0 is a C, 5, 0 is an E, and 4, 0 is a D. So unfortunately, something I didn't get to cover, I guess I can do a second example after this, is sometimes you will just get like 2 or 3 as the first number in a pair. However, that's not going to be in the pair. Let's say instead of like 4, 0, we had 2. So we look at row 2, oh, that doesn't exist. So instead we just use the letter underneath the 2 here. So in this case, if this was just a 2, we'd have a K here. So that's what would happen. But we don't have that, so we have 4, 0, and we get our keyword 3 advanced. Keyword 3. So now, let's move on to the next step. Step 2. Stunted blind polyphia cipher. So it requires the 8-letter keyword, which we have here, and the encrypted word concatenated from the top and middle screens on page 1. So let's write that down. So IDGBAAMHD. So the following diagrams will be used, since we have something 1, 2, 3, 4, 1, 2, 3, 4. Just put dots here for now, as well as this braille configuration. So we need to fill the polyphia square with the letters A through P, but we need to take keyword 3 and basically do the alphabet. The whole shenanigans. So in this case, we're going to be removing advanced from this, as well as any letter after P. So Q, R, S, T, U, V, W, X, Y, Z. I should remove these brackets, and that's what we have. V, we don't have, so all of these come before P. Let's remove any duplicates. These are our duplicates. Okay, so if the 1 bit is a 1, which is alphabet goes after the keyword. So we have it like this. So this is going to be filled in to this table here. So let's do that. So this is the table, and now we need to label the rows and columns of the blind polyphia square on the right here. So our keyword was advanced, so we need to label the columns with numbers 1 through 4 based on the first 4 letters, alphabetical order. So if we just have dots here and then dots below it, A, D, V, and A in alphabetical order. But we have 2 A's, so in this case we go from left to right. So this is the 1, the second A is the 2, this third is D is 3, and this V here is 4. And for the rows, we'll use the last half. So C comes first, so that's 1. D comes second, so 2 goes down here. 3 is right here, and 4 is right here. So now we take this encrypted word, which is right here, letter by letter, and find its position in this braille. So we start. Actually, you know what I'm going to do? I'm actually going to take this rows and columns, and I'm just going to rearrange this up here so it matches this. So it goes 4, 1, 3, 2, just like this. So let's find I. In this case, it would be 3 and 2, which we've rearranged here. So we're just looking at this position. We're going to write this down. And this, I'm going to write this down vertically. So D is in this position. So this is going to be like this. G is right here. So we have this dot configuration going on. B is bottom right. So that's all dots. A is over here, so we have that twice, so we're going to do this twice. M is in the top right, so it's dot, dot, empty, empty. H is right here, so it's dot, 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 empty. And then D is in the middle right, so we have this and this going on. So, if we split these up into each 3 rows, we're going to have a 6-letter braille word, which is nonsense at the moment. But it will come out to valid braille. So this first letter is a Y. Second letter, I believe, is a Z. Oh, we don't have a braille, so I'm going to have to open this up because I don't have this memorized. Okay, that's a Z. We have a G, a K, a C, and I believe this is a T. Yes, it is. So through this braille, we have our next encrypted word, which is this set of letters. And that's step 2 done. Step 3 is chain rotation cipher. So the encrypted word from step 2, which is this, and the number on the middle screen on page 1, in this case it's a 2, which we're going to call N. So we need to take this word and cycle the encrypted word left by N positions. So we'll do that. Take the first 2, put them at the end. It's easy to shift the leftmost letter forward by the alphabetic position of the last obtained letter. But we don't have that, because this is the first letter, so what we're going to do is we're just going to extract this G. Next, we shift this left 2 again, and we take this T. So we need to take the previous letter, which is G, plus the alphabetic position of T. In this case, that's 20 plus 7 is 27. Subtract 26, we get 1, which is A. Then we remove that. We cycle this left by 2 again. A plus K, so it's 1 plus 11 is L, so we remove that. Cycle this by 2. L plus 26, or 12 plus 26 is something, not 26, it's just going to be 12 again, so we put an L. Cycle this right, doesn't matter. 12 plus 3 is O, and I suspect our word is going to be gallon, but we can confirm that. So 15 plus 25, I don't know what this is. Oh shit, 15 plus 25 mod 26 is 14, which is N, yes. So that's our word, gallon.